Hello everyone. Today we from Group 3 will be presenting about experimental 7, which is stability of a floating body. Before that, I would like to introduce my fellow group members. The first one is me, Chirawat, and the second one is Muhammad Irfan bin Ramizul, following by Muhammad Afiq bin Muhammad Sabri, Muhammad Haikal bin Badaru Sham, and Nur Hazwani binti Muhammad Sabri. So this is our content for our presentation. So we will start with the introduction. The system's potential energy has a minimum value when it is in a stable equilibrium. This feature is used to construct a formula that can be used to determine the floating body stability. Floating body stability is said to be in a stable balance if its center of gravity is at least as high as a related center of buoyancy. The metacentric height, which is Gm, is a measurement of the floating body's initial static stability. It is defined as the distance between the ship's center of the gravity and its metacenter. The greater initial stability against overturning is associated with a higher metacentric height. So next, we will move to the objective. The objective of this experiment is to determine the height of the metacenter using the tilting method. So that's all for my part. I will pass to the next presenter.
Hi, Assalamualaikum and good day to everyone. The last experiment in this semester, I'm Muhammad Irfan bin Ramizu will present my part, which is a theory. For theory, the knowledge on the stability of pontoons such as a floating ship is vital. As depicted in the figure for the next slide, a floating body can be stable even though the center of gravity lies above the center of buoyancy. This is true since a body rotates, a buoyancy force will act on the center of the new volume displaced, which is from the restoring couple of the wake. Hence, the body to return to the original equilibrium position. However, for the relatively tall, slender body as shown in figure in next slide, a small rotation displacement can cause a buoyancy force and the wake to form an overturning couple, which lead to the unstable configuration of a floating body. Okay. This figure shows example for the stable and unstable of floating body. Okay, in this experiment, the stability of a pontoon is determined with the center of gravity at the different height. In a horizontal wake is moved with a distance from the center. The pontoon with tilt. The angle of tilt can be measured by using the plumb bob. The equilibrium condition of floating body can be determined experimentally as follows. Okay, in this experiment we use many equations. For the first equation, overturning couple, which is CO equal mgx. Next, second equation is righting couple, CR equal capital Mg time with capital Gm time with tangent theta. Okay, next, third equation for the equilibrium condition, which is CO equals CR. Then we can fit the equation, get capital GM equal WX over capital W times with tangent theta. The result obtained from the experiment can be compared with the calculation method. For calculation method using area of second moment as follow. So in calculation method, equation 4, which is capital BM equal I over V, which is I we can get from LB cube over 12, and V we can get from V equal W over rho, capital W over rho. Thus, Gm equal Bm, capital Bm minus capital Bg. And the fifth equation we can get capital Bm minus By minus Y plus D over 2. Okay, next we move to the symbol in this equation. Whereas M represent a mass of horizontal weight in kg. Next is G represent a gravity constant, which is 9.81 meter over second squared. S is distance by which the horizontal weight is moved. Capital M is total mass of pontoon in the vertical wake. Theta is angle of tilt. Capital GM is distance between the body center of gravity to the center of matter, while the capital BM is distance between the center of buoyancy to the center of matter. Next is capital BG is distance between body center to the body center of buoyancy to the center of gravity. Okay, next is capital I is second moment of water surface area at vertical axis, while capital L is length of pontoon, capital B is width of pontoon, capital V is volume of displaced water, rho is density of water, Y is distance between the base of pontoon to the center of gravity, and the lastly D over 2 is distance between the base of pontoon to the center of buoyancy. Okay, that's all for me. Thank you.
For the methodology, Step 1. Remove the horizontal wake and fix the height of the vertical wake on the mast of the pontoon. Step 2. Determine the center of gravity CG by putting the pontoon mast of the pontoon stabilizer. Measure the length of the CG, which is the half distance from the base of pontoon to the center of vertical wake. Step 3. Fix the horizontal wake and ensure that the thread is at 0 mm position, nor tip. Step 4. Fill the tank with water and place the pontoon in the tank. Step 5. Measure the length of the pontoon, which is submerged in the water. Step 6. Move the horizontal wake 10 mm to the right and record the angle of tip of the thread. Step 7. Repeat step 6 by moving the horizontal wake to the right with 10 mm increment. Record the angle of tip. Repeat this step until the plumb bob, which is hanging on the thread, touch the side of the pontoon. Step 8. Repeat step 6 and 7 by moving the horizontal wake, this time to the left. Step 9. Adjust the height of the vertical wake to the new height and repeat step 1 to 3 followed by step 5 to 8. Do this test for 2 different values of vertical height.
Hey, it's me Haikal. For experiment of stability of floating body, I'm going to present and discuss more about the result and discussion part. So without further ado, let me get started. For the result part, we got 3 tables in here. The table 1 is for the test 1 on the top. The table 2 is the test 2 on the middle. The table 3 is for the test 3 on the bottom part. So as you can see here, for the table, the lecturer has provided us with the data for the movement to the right, x and theta, and the movement to the left, x and the theta. So for our task, we have to calculate the metacentric of height that has given the formula above. So after we calculate with the formula, we get this data. So from the data, we have to plot the graph. So we are using the Microsoft Excel to plot the data. After we plotting, we are given the equation of the straight line. As you can see at the screen is for the graph for the table test 1. Here is the graph for the table test 2 with the equation of the straight line, and here is the graph for the table test 3 with the equation line 2. So next we continue to the discussion part. For the discussion part, I will cover for the question 1 Roman. The question stated that value of GM metacentric height from the plotted graph when theta equal to 0. From the graph, we can conclude that when theta is 0, the value of metacentric height. So, as you can see in this answer sheet, as you know, when theta is equal to 0, the theta is equal to x from the equation this. So as you can see here, we can use only the equation of the straight line on the each of the graph. So for the test 1 graph, the equation of the straight line is here. So we just need to replace x with 0. So after we replace, the answer we get for the test 1 is 37.7 mm. For the test 2, we got 62.158 mm. For the test 3, we got 82.194 mm. So that's all for me. Next, we will proceed to Nur Hazwani.
Hi, I am Nur Hazwani. Next, I will continue with the second question from the discussion part, which is calculate the value of GM for each test using an area of second moment. Compare and discuss the obtained value with the value of GM from 1. So, first thing first, we need to know the formula, which is GM is equal to GM minus Y plus D over 2. So, here we find the value of GM first, which is I is over V, and then we got 200.17 millimeter. So after we got this value, we need to plug into the formula. Alright, as you can see here, GM on test 1 we got 80.67 millimeter. GM on test 2 we got 109.17 millimeter. And GM on test 3 we got 133.67 millimeter. So here the table of comparison between the theoretical GM from calculation and the experimental GM from plotting graph. So as you can see here, the theoretical GM from calculation on test 1 we got 80.67, while experimental GM from plotting graph we got 37.7. And for test 2, the theoretical GM from calculation we got 109.17, and experimental GM from plotting graph on test 2 we got 62.158, and theoretical GM from calculation on test 3 we got 133.67, and the experimental GM from plotting graph we got 82.194, okay, on test 3. So if we compare the value of GM computed or calculated using an area of second moment to the value of GM from the graph, we see that the two values of GM are significantly different. So the area of second moment equation is affected by the distance between the pontoon's base and the center of gravity, the length of the pontoon submerged in water, and the volume of water displaced. Next, moving on to the third question. Discuss the reliance of the metacenter on the position of the center of gravity in terms of stability of floating body. Right, the stability of floating body can be measured by the metacentric height GM. As GM increases, the stability of the body increases. When metacenter is above center of gravity, then a restoring moment will be produced to restore the stability when the pontoon tilts. If the metacenter is below the center of gravity, then the overturning moment will occur. Therefore, metacenter relies or depends on the position of center of gravity. Alright, next, moving on to the fourth question. Discuss the effects of variation in angles of tilts on the position of the metacenter. Right, so here are the formula or equation. Gm is equal to Wx over W tan theta. So the position of metacenter will affect by the variation in angles of tilt. The horizontal weight shift to left or right at the various angle that will produce various position of metacenter. So from the above equation, which is this one, we can see that the Gm is inversely proportional to tan theta. Thus, the smaller the tilt angle, the greater the value of Gm and vice versa. Like the greater the tilt angle, the smaller the value of Gm. Okay, so we're moving on to the conclusion part for this experiment. Alright, in conclusion, this experiment was conducted to figure out the height of metacenter or GM by using tilting method and to investigate its stability. The point of metacentric M changes and always depend on the center of gravity G of the body. We can conclude that when the metacenter is above the center of gravity, the floating body is stable and the Gm will be positive, which is our Gm is greater than 0. On the other hand, the floating body is not stable when the metacenter is below the center of gravity, and the Gm will be negative, which is our Gm is less than 0. The larger the length of metacentric, the more stable the floating body. So here's our references for this experiment. Alright, that's all from us and thank you for your time. See you next time.